So what happens when a liquid becomes a gas? That's going to be the topic of this video. At the end, I'm going to talk about a huge mistake, a major misconception that so many people make when they're dealing with this topic. So make sure you watch this to the end, or if you think you already know all this stuff, skip right to the end so you can learn what this mistake is, and you will never, ever, ever make it yourself. Okay, so let's start looking at this topic by examining something that I'm sure you've seen happen in everyday life. Let's say that I have a glass, and I fill it up with water, and I leave it on like the kitchen counter overnight, okay? In the morning, I come, and the glass used to be full, and now most of the water looks like it's disappeared. The water level's way down here. What's happened? Has the water just disappeared? Where did it go? Well, as you probably know, what happens is the water evaporated, which means that the water that was liquid turned into gas, and it floated away. It floated off into the air. This is evaporation. And evaporation is a type of what we call vaporization. Vaporization is that kind of a catch-all term that we use whenever, anytime a liquid turns into a gas. So the water disappearing from the glass of water overnight is an example of vaporization. So this is like a real-world example that you can actually see. Here's what I want to do now. I want to pretend that we have like a magic microscope or something, and we can look at this glass of water and we can zoom in on it and look at the atoms and the molecules that make up this glass of water so we can see what vaporization looks like at the molecular level, okay? And it turns out that I don't want to just zoom in anywhere in this glass of water. I want to zoom in on a very specific point. I want to zoom in right here at the surface of the water where the water meets the air, okay? So let's take our magic microscope, or whatever we want to call it, and zoom in right on this surface. If we could actually do that, check it out. This is what we'd see. We'd see a whole bunch of these kind of triangular things, which are water molecules. They're made up of one oxygen atom bound to two hydrogen atoms. We have an oxygen and two hydrogens. And there'd be a ton of them here. The top of these, the top of where these molecules is the top of the water, and then we have the air above it, okay? Now, there's something that I can't really show with these water molecules here, and that's that if we were really looking at this realistically, they'd all be moving around a little bit. They'd be jiggling around, some of them would be spinning around and turning. And so imagine, if you can, that all of these guys here are in constant random motion. They're bumping into each other and they're all moving, swimming around and jiggling around. Now, when vaporization happens, one of these guys is going to be moving a little bit faster than the others. And he or she is going to make it to the top, to the surface of the water, and they're going to be moving fast enough that they can jump right out away from their buddies and float out into the air. And now this molecule, that used to be a molecule of liquid water, has become a molecule of water gas. And now maybe down here, somebody else is moving a little bit fast. They're moving fast enough. They make it up to the top, and they're able to jump out and become gas. And now we have two molecules of water gas, and then one more is moving fast enough that it can jump out and become a gas. So this is what happens when, say, liquid water becomes gaseous water. One of these guys is moving fast enough that it can jump out of the water and enter the air, becoming gas. Okay? Now, here is a huge mistake that so many people make when they're talking about vaporization. Make sure that you don't make this mistake yourself. They think that when this water molecule turns into a gas, that somehow the atoms that make it up come apart, okay? That like it looks like this when it's a liquid, but then when it jumps out and becomes a gas, the hydrogens and the oxygens come apart, and then this thing is made up of individual atoms. The atoms all split apart. Okay, that does not happen. Don't make that mistake. The water molecule, when it's in a gas, looks exactly like it did when it was in water. We have 1 oxygen and 2 hydrogens. And that's why we call the phase change where liquid becomes gas. We call that a physical process, not a chemical process. Because in a physical process, you don't alter the composition of the compound. We still have 1 oxygen and 2 hydrogens even when the molecule is in gas form. Okay? Now, this isn't just true for water. All right, so don't think that that's the only case. What you learned is exactly the same for any other molecule. Let's take a look at gasoline here. Gasoline is a little bit more of a complex molecule. It has 8 carbons surrounded by 18 hydrogens, okay? And if we could look at a tiny sample of gasoline, liquid gasoline, it would look like this. We'd have all these molecules, and they'd be kind of packed together, but again, I can't show this particularly well. They'd be moving around. One of them or 2 of them would be moving fast enough that they'd be able to jump right out from their buddies and they'd float away into the air. And the gasoline would vaporize just the same way the water molecules vaporize. And again, what's true with the molecules of water is no different with the molecules of gasoline. So it would be wrong, do not make this mistake, to think that gasoline, when it's going from liquid to vapor, would somehow break apart into the atoms that make it up. That doesn't happen. The molecules that make up gasoline or water or anything look exactly the same when they're in gas form as they do when they're in liquid form. It's just they're not so close together moving around. Instead, they've broken away from their buddies and they're floating out here in the air. So that's what happens when a liquid turns into a gas, and never, ever, ever make the mistake thinking that the atoms that make up a molecule come apart when it becomes a gas. It doesn't happen.